Hello, viewers. In today's session, we are going to discuss a very important and conceptual problem from derivatives, right? And here we are going to discuss this problem where we are given a function f which is twice differentiable, and we are given some conditions that is f double prime of x is equal to a negative of f of x, and f prime of x is equal to some other function, say g of x, right? So f is twice differentiable, and we are given these two conditions. So f double prime of x is equal to negative of f of x, and f prime of x is equal to g of x. And further we are given a third function p of x, which is equal to the sum of the squares of the functions f of x and g of x, that is square of f of x plus square of g of x. And here these conditions are valid for all values of x belonging to the set of real numbers, right? So now we are given p of 2 is equal to 5. Then we have to find out the value of p of 5, right? So when x is equal to 2, then the value of the function p of x is equal to 5, and we have to find out the value of p of x when x is equal to 5, right? So let us see how easily we can find out the value of p of 5 by using the concept of derivative and making use of some simple algebra. So now let us differentiate this function p of x with respect to x, right? So taking the derivative of both sides, we have d by dx of p of x, and here we have d by dx of f of x square, and here we have d by dx of uh, the square of g of x. So this is p prime of x, and now here we have to find out the derivative of the square of the function f of x, right? See, we can write d by dx of f square. So for simplicity, we can take f in place of f of x. So taking the derivative of f square with respect to x is 2f times df over dx, and this is due to chain rule, right? So here first we have used this result, that is the derivative of x raised to n with respect to x is nx n minus 1. So first we have taken the derivative of f square with respect to f and applying this rule, and then by chain rule we write df over dx. So the derivative of f square is simply 2f due to this result, right? So we can now write here 2f times df over dx, and again replacing f by f of x, we can write this notation as f prime of x, right? So we have f prime of x, and here for f we can write f of x. And similarly we can write the derivative of the square of g of x. So we can write 2 times g of x and g prime of x using a similar reasoning. So now we have this important equation. Now let us come to this one. So here we are given that f prime of x is equal to g of x. So let us differentiate both sides. So differentiating both sides with respect to x, we have d by dx of f prime of x, that is equal to d by dx of g of x. So we have f double prime of x is equal to a g prime of x, right? and f double prime of x is given as negative of f of x. So replacing this f double prime of x by negative of f of x, we have minus f of x is equal to g prime of x, right? So now what we will do, we'll replace this g prime of x by this one, that is negative of f of x, and f prime of x by g of x in this equation, right? So we have 2 times f of x. So f prime of x can be replaced by g of x, and then we have 2 times g of x, and g prime of x can be replaced by a negative of f of x. So now let us write this equation as 2f of x g of x, and here taking this negative sign in front of 2, we have minus 2, and here first writing f of x and then g of x, and we can see that these two quantities are same, so their difference is equal to 0. So 2 times f of x g of x minus 2 times f of x g of x, the difference is equal to 0. So we have arrived at an important result, that is the derivative of the function p of x, that is p prime of x is equal to 0. So we can now write dpx over dx is equal to 0. So whenever the derivative of a function is 0, then the function is a constant function, right? So p prime of x is equal to 0. It implies that the function p of x is a constant function, and let us write it as k, where k is some constant. So we have arrived at this result, that is p of x is a constant function. So now we are given that p of 2 is equal to 5, right? So when we take x is equal to 2, then we can write from this equation, by taking x is equal to 2, we have p of 2 is equal to k, right? And p of 2 is given to be 5, so p of 2 is 5, so k is equal to 5, right? And now we can easily find out the value of p of 5. So taking x is equal to 5 in this equation, we have p of 5 is equal to k, and k is equal to 5, right? So p of 5 is equal to 5. So now since p of x is a constant function, so for all values of x belonging to the set of real numbers, the value of px remains the same as k, right? And we have just seen that the value of k is equal to 5. So we can now write the function p of x is equal to 5, right? So this is the form of the function p of x, that is p of x is equal to 5, and in the given problem we have to find out p of 5. So p of 5 is equal to 5.